All right. Welcome, everyone. My name is Dan Vega. This talk is, does your API need a REST? Check out GraphQL. This is going to be an introduction to GraphQL in Spring applications. So a quick show of hands. Who has heard of GraphQL? Who has actually used GraphQL in an application? All right, perfect. You guys are my audience. Cool. Quick note from the lawyers. The lawyers asked us to put this up, so I'm sure you read it thoroughly. If you want to, you can learn a little bit about me at danvega.dev. If you don't know who I am a Spring Developer Advocate at VMware. I often joke that I've been a Spring Developer Advocate long before VMware was actually paying me to do so. I'm a huge fan of Spring and this ecosystem. I am a husband and a father. I live outside of Cleveland, Ohio. I like to create content, so this is kind of, I love going off and learning new things and then kind of teaching that back to others. So this is really a perfect fit for me. You can find me on Twitter. I enjoy running, I enjoy golf, both of which I'm going to get to do this week. We have a little 5K tomorrow morning. It's a little out and back, even if you don't run 5K. If you want to do like just a half-mile walk, meet us in front of the Venetian main entrance at 7 a.m. We're going to do a little fun run together. And I'm also golfing later this week here in Vegas with my friend Nate. I also run a show called Spring Office Hours. This is a live stream that we do every Tuesday. We're actually going to do one live tomorrow. We've also turned this into a podcast, and this was Deshaun and I's way of kind of creating something that we wish we had when we kind of got into Spring. We often cover what's new in the community. We answer questions from you. Again, this is a weekly resource that you can go ahead and take advantage of for free. So what I want to cover today when it comes to Spring, I want to tackle the problem of why. Why do we want to learn this? Why do we want to learn GraphQL? Why do we want to use GraphQL in our Spring applications? I always start with the why. I don't want to just learn something to learn it. I need a reason to. So once we understand the why, I'll jump into a little bit about what GraphQL is, how we can get started with GraphQL in our Spring applications. Once we understand all of that, I'll cover a couple of the high-level, really cool features in Spring for GraphQL. So first, I want to start with why. What problems are we trying to solve? So I want to start by using this fictitious company called Waffle Corp, mainly because I love waffles, and this picture I love this picture. So Waffle Corp has a bunch of products, right? They serve to, they have these products that are direct to consumer, and then they also have these strategic partnerships. So the application that we're currently working on is built in a monolithic Spring Boot app using Spring MVC, has a REST API, the front end built in something like Vue with Tailwind CSS. Management has come to us and said, hey, we need to open up these REST APIs for some of these partner microservices that are selling our products. Also, we're working on iOS and Android applications, and we need to open it up to that as well. We also have an idea to build some IoT applications. So we need our APIs to be able to communicate with that. So we have a typical application here. We have a front end. We call into our Spring Boot application, which is a REST API. In the REST world, we typically build this out and separate it into different resources. This is going to talk to a database and return some data. These resources are different resources like products. We have reviews. We have orders, and we have customers. So each of these are different resources in our system, and we kind of treat these as separate resources. So we have this application, and we've been asked to do these different things, right? So we typically don't think about constraints when we're building out kind of desktop applications, right? When we ask an API for a bunch of data on the desktop, we don't really care about things like screen real estate. We know it's there. We don't care about performance. We know somebody's probably on a really good connection. So these are typically not things we think about. But when we start building out these other services, we're going to have to think about them. So think about it like an iOS or an Android application talks to our REST API. They may not want to return 40 or 50 different fields to display. They may only want 4 or 5 of those fields. So we got to think about those things. When our partner microservices are calling into REST API, we got to think about things like security. We may not want to show all of these fields to them, right? When we start building out an IoT application, this may only want to talk to the REST API and return a couple fields, right? Even less than our iOS applications. And maybe we have a fridge that talks to this API. So these are some things that we start to think about as we're building out a REST API. When it comes to GraphQL, we have a single endpoint. We don't have all these different resources. We have a single endpoint, and the client gets to ask us for whatever information they want. And this is very important when it comes to GraphQL. So I have another example here, something else that I come across a lot in enterprise applications. So I have this REST API for these products, and I want to get some information about the product. So I make a call to this API to get a GET request to /product/123. So I get some data about the product, and I realize, oh wait, I need some more information about it. I want to display related products on this page as well, so I make another call to the API to get related information. And I make one more call to get reviews about that product. So at this point, we've made 3 different calls to the API to get all the information we need to display on that page. With GraphQL, we don't need to do that. We can make one single call to an endpoint at post endpoint to /GraphQL to get all the information that we need for that particular request. So when it comes to why GraphQL, I think one of the, there are a lot of different reasons to do so. Some of the things that really stand out for me is no more overfetching of data. If I am a resource or if I'm a client like an iOS application, I can ask for only for the data that I actually want. I no longer need to make multiple requests for multiple resources like we saw in that previous example, which leads to a waterfall network requests on nested data. Each client needs to know the location of each service. We have a strongly typed schema, and there's a lot of really great tools in the GraphQL world for developer tooling. So that's my why. What is GraphQL? So the first part of the word, graph, it really deals with building out a graph of information for your API. The QL is for the query language side of things. So a little bit about the origins. This really started at Facebook back in 2015, where they had a lot of similar problems, right? They're building out these iOS, these Android applications, and Facebook has a ton of data. They don't need to return all of that data on the mobile app that they were returning on the desktop app, right? And they had all these different microservices that they needed to call to kind of aggregate all that data together to pull it in. So they came up with GraphQL. This was open sourced in 2015, and once it was open sourced, it's no longer run by Facebook. It's actually governed by the GraphQL Foundation. So if you want to learn more about them, you can do so there. So I like to point this out that GraphQL isn't tied to any specific database or storage engine. I often get questions like, how do I do data retrieval in GraphQL? And if you're asking that, you're kind of asking the wrong questions, right? We don't ask that in REST. We kind of delegate that to something else like a service layer or a repository. So GraphQL isn't tied to any specific database. So there are 2 sides to GraphQL, right? We have the client and the server. On the client, we have a custom GraphQL query language. It kind of looks like SQL, kind of looks like JSON. It's a domain-specific language for writing queries. The nice part about this is it's crafted based on the needs of the client. No longer are we writing all these different REST endpoints to cater to whatever the client wants. The client now gets to ask us for what they want. And again, it only returns what the client asks for. There's some really good tooling on the client side. We'll see an example of that later today. So what we care about, on the server side, there's a GraphQL schema that defines our API. This schema is based on a simple static type system. I like this because even if you're not used to GraphQL, there's a very simple type system, and it's easy to get up and running with it. And it's nice because it's implemented in specific languages based on a specification. And for me, that's important. That means like when I go to a JavaScript app or a Spring app, if I'm using GraphQL, I'm pretty familiar with my environment because this is not just created out of the blue. This was based on a specification, right? So client and server, 2 sides to kind of the GraphQL story. There is a specification out there if you want to read through it, and you have a whole lot of time on your hands, you can go through it. But the first part that you'll see in there is what defines the type system. So on the server, we have this type system, and the first thing that we start with is object types. So an object type is like the things that we saw earlier, like our products, our orders, customers, reviews. And the way that we create them in the schema is by using the type keyword and then the name of the object type. So we have a product, we have an order, and what happens is on the left side are all of their fields for that object type. So we have ID, title, description. On the right, we have the different types. And in this case, the ID type, the exclamation point is saying, hey, this is never going to return a null, so it's not something that you have to kind of think about in your code. So we have built-in Scholar types. We'll see on the next slide that there are 5 of them. We can use built-in Scholar types. We can also reference other object types. We can even use custom scalar types, which we'll see some more in a little bit about. And then we can use things like enums and interfaces. So the GraphQL schema, those scalar types that I was talking about, built in are int, float, string, boolean, and ID. That ID is that unique identifier. Again, you're probably thinking to yourself, I'm going to need more than this in my application. Of course, we can define custom scalar types later on. So most of the types in our system are going to be those normal object types, the products, the customers, et cetera. But there are three special ones that are kind of special to GraphQL. And that is the query, mutation, and the subscription. So a query is, hey, I want to get some information out of the API. I want to get a list of products. I want to get a single product. A mutation is, I want to change some data. I need to create a new product, update a product, delete a product. A subscription is similar to a query, except that it just leaves a connection open. You could think of like a stock ticker where I continuously need to read data. So we have object types and operation types. Those two things alone will get you a really long way. So we have our product type that we defined before, and we need to create some queries. We use the type keyword, we have query, and then on the left, same as we did before, we have fields. So the field names are all products and get product. On the right is the return type. The all products is saying, hey, I'm going to return a collection of products denoted by the brackets. And again, the exclamation point there is saying, hey, you don't have to work for a scenario where this is null. It may be empty, but you'll never have to worry about null. We also can take arguments, and this is where it gets really interesting, which we'll touch on in a bit, but the field on the left is the name of the field, on the right is the type, and then the exclamation point saying, hey, if you're going to pass me an ID, it better not be null. We also can have enumeration types, so as Java developers, we should be pretty familiar with this. The status is of order status, and we set up an enum for order status with those possible values. We can also use interfaces. So I have an interface called review that says it must have a title, body, and rating. So within my schema, I create a new type called product review that implements that interface. It needs to include those, but in this case, it's also declaring a product field. And then I have an order review that implements that includes an order field. So again, arguments is where it gets really interesting, right? Just with operation types and object types alone, you can go a long way. But where it gets interesting is the kind of building out the graph part of GraphQL, and that's where arguments come in. So you can imagine a search customer by full name, where I take in a first name and a last name. Because I can take those in as arguments, that's going to return some subset of data. Then I can kind of build that graph out by using arguments. And then I can also say, hey, these are required arguments if you want to go ahead and pass those in. So in REST, you can only pass a certain set of arguments, right? Or a certain set of parameters. You can use request parameters. You can use other things as part of the request URL, the path. But in GraphQL, we take these arguments, and then we can start to build out the graph. So I have this customer. That customer is going to have a field on there called orders, and that order has other things like product information. So based on that, I could say, hey, I want to find a customer by an ID of 99, but I don't just want all the orders included in that. I want to kind of I want to filter that down based on some criteria. Maybe I only want the first 5 orders in that collection. So these arguments are where we really get to start to build out the graph part of the GraphQL. So we saw some arguments that we were passing in. What if you need to have variables where these arguments are dynamic? So we can create that find by customer ID, where the ID is 99. We pass in, on the order side, we pass in that first of 5. In Graphical, which is a tool I'll show you a little bit more in a second, we can go ahead and define those variables. So we defined a variable called customer ID, and then we go ahead and supply that down there. So it just allows us to pass dynamic arguments to our GraphQL queries. Cool, so those were kind of queries and arguments. We talked about another special operation type, which is a mutation. So I have a mutation here that I've declared that allows me to create a product. That create product field takes in a couple arguments, the title, which is a string, the description, which is a string, and it returns a product. So you might think that, okay, this is pretty good for just those 2 fields, but what about when I start to have like 5 or 10 fields? I need to have some type of type here that I could pass into it. And you might think to yourself, well, I'm just going to pass in a product as an argument here. The important part to note is those object types that we are creating, those are output types. They cannot be used as input as an argument in GraphQL. So whenever we want to pass an input in, we need to create something called an input type. And the way that we do that is by using the input keyword. So we have an input type called product input. And yes, it looks pretty similar to that, but now we can kind of forge a different input type for different types of scenarios, right? So we have this product input, and we can pass that as an argument to our mutation. Okay, so why GraphQL? What is GraphQL? Cool, we got some foundation here. How do we get started in Spring? So the two projects that we're really talking about here today are GraphQL Java. It was really cool seeing Andy Mark up in the keynote during one of those videos. He is the founder of GraphQL Java and the Spring for GraphQL team. So these 2 teams worked really closely together to kind of put this into action. So let's start with GraphQL Java. This is the implementation of the GraphQL specification in Java. As I said, if you want to kind of have a server side of this, you need to implement a specification. There are a few. This is by far the most popular. Again, we saw that Facebook open sourced this back in 2015. This started really shortly after that by Andy Mark, who is a software architect at Atlassian. There's a really good episode on Josh Long's Beautiful podcast where he interviewed Andy. If you want to hear like the origin stories of kind of how that GraphQL project got started, I highly recommend checking that out. So GraphQL Java is just purely an execution engine. It knows how to take those queries that you're asking for and submit it to the server. But there is no kind of transport layer with GraphQL Java. There's no way to send it over HTTP or no I/O, no high-level abstractions. And that's where Spring will come in just a second. Very active on GitHub. It adds those custom scalar types. So past those first 5 that we looked at, if you need things like date and date time and UUID and all the other things that you're probably thinking in your head you're going to need, that's where GraphQL Java comes in and kind of gives you that ability to add those. Check out graphqljava.com. You can use it independent of Spring if you just want to learn how that works before you dive into Spring. There's also a really good book that Andy Mark and I think his coworker wrote, Donna. It's called GraphQL Java with Java and Spring. Really good book that I've kind of gone through like at least half of it already. Really interesting, so go ahead and check that out. So what does GraphQL Java give us? We just talked about it's an execution engine. What does that mean? So when I type those queries out, so I'm asking here, hey, find all the customers by last name. I'm passing an argument in, and these are all of the things I want back. So remember, in GraphQL, I have to be very specific what I want back. I can't just say select star. These are all the things I want back. I want ID, first name, orders, inside of orders. There's a product. These are the fields on product I want. So I'm being very specific with what I want back. That is known as a selection set. So in that selection set, we need to have corresponding data fetchers on the server so that when you ask for something, we know exactly how to get it. So GraphQL Java will take that query that you're sending to the server, it knows how to execute it, tie it to a data resolver, data fetcher, and execute that. So that's the GraphQL Java side of things. So what is Spring for GraphQL? Where does this come into play? So Spring for GraphQL provides support for Spring applications built on GraphQL Java. Again, a great joint collaboration between both teams. It brings in the kind of Spring programming model. For me, that's making all the kind of infrastructure stuff hidden away from me and allowing me to kind of focus on building out my applications. We'll see what that brings in, which is like a Spring Boot starter. There are some different versions of this. 1.0 was released in May of 2022. So if you're on JDK 8, you can still use that with Spring Boot 2.7. The latest release is 1.2.x, which was released earlier this year in May, and that supports Spring Boot 3.1, JDK 17, and GraphQL Java 20. So what does that mean? So our same selection set that we were talking about before, now we have a way to kind of transport that. Now we can support HTTP, WebSocket, RSocket, however you're going to send that selection set over, however you're going to transport that query, that sits on top of the GraphQL Java engine. Now, we talked about data resolvers before, data fetchers. How does that work? Well, in Spring, it's a controller programming model. So in Spring, we define a controller, and we have ways to map methods to the different data fetchers, or define data fetchers, so that when you ask for something, we know how to go out and get it. So we've kind of defined what GraphQL Java is, what Spring for GraphQL is. Cool, how do I create my first GraphQL API? So obviously, head over to start.spring.io. We're using, in this case, 3.1.2. We fill in some information about our application, and we define our dependencies. So the dependencies are, I need a transport layer, right? Am I doing this over web, HTTP, WebSocket, RSocket? What's that transport layer? In my case, I'm just building out a Spring web application. I'm going to choose Spring for GraphQL as one of the dependencies. And in my case, I need to talk to a database. Again, GraphQL isn't specifically talking to a database. We're delegating that to something else. In this case, that's Spring Data JPA, and that's going to talk to an H2 database. So we have our dependencies, we generate our project, we open it up. What does that Spring Boot starter give us? Well, it gives us dependency management. So it knows things like what version of GraphQL Java we should be on, among other things. It gives us auto configuration. It configures GraphQL Java. It does all the things behind the scenes for us that you would normally have to manually configure. There's a bunch of properties in there that you can go ahead and set. Out of the box, you're going to get metrics. We'll see an example of some observability later, but we're collecting metrics on everything that's going on behind the scenes. There's a really nice graphical UI page that allows you to kind of prototype or explore the different queries in your system. And then it gives you testing support out of the box. So we've created our application. We need to create the schema. We talked about everything on the server starts with the schema, right? So in my Spring application, I've created an entity. I have a product entity, and it has 3 fields on it: ID, title, and description. Now, this is a very basic example, but you can imagine this having a lot more fields, right? Like maybe I have 40 fields in here. But maybe I don't want to expose all of those fields in my API. This is why we very much take a API-first approach. So in our project, there's a GraphQL folder under source main resources. And what we're going to do is any file in there that ends in GraphQLs, we will pick up and try to inspect as a schema. So in this case, I'm just calling it schema.graphqls. Now, we talked about how to build this schema out before, right? Like we have our different object types, we have our different operation types. So I'm saying, hey, we know we have a product in our system. In this case, I'm saying I want the fields ID, title, and description to be available in the API. Again, if we had a lot more fields here on the Java side, on the Spring side, I could still limit that in my API, but just declaring the ones that I want to return in the API. So I have this object type, and then I have a type query called all products. So all products is going to return a collection of those products. So just that little bit on the right there, that has defined a schema in our system. We have basically defined an API, a GraphQL API on that side. So once we have that, we need to kind of tie this to Spring, right? We have our schema. How do we kind of connect it to the things that are working in Spring? So we do that by defining a controller. So I have a class called product controller. It uses the @controller annotation. And what that is doing to GraphQL is saying, hey, go ahead and look in this controller for some type of schema mapping. If you look at that method down there, the findAll method, which is returning a list of products, we have an @schema mapping annotation. So what this is doing is saying, hey, I want to go ahead and tie this to my schema. So when you ask for a query that says, hey, I want all products, how do we kind of tie those two together? And what that does is, in the schema mapping, there's a type name. So what is the type? The type is query, mutation, or subscription, right? In this case, it's a query. The field name is all products, the field name in the schema that we defined. So now when somebody asks for all products, we know on the Spring side how to kind of resolve that. So if somebody asks for all products, this is the method that's going to be called. So that schema mapping annotation is nice, but it's a little verbose, right? I want to cut down on that. I can do so by using a specialized version of that. The similar way to, so like a request mapping annotation, we have specialized versions of those like get and put and delete. We have a specialized version of that called @query mapping. So that just suggests that the type name is going to be query, and then if the field name in the schema, so all products, is the same as the method name over there, we can kind of clean that up. Now all we need is an @query mapping annotation. So when all products is called, this is the method that is called on the Spring side. So now we've kind of tied those two together. There's something new in GraphQL, I think 1.2, which is the schema mapping inspection report. As you're kind of developing your applications and you're building out your schema against all your types in your system, you might come across some mismatches, and sometimes those can be a little bit hard to debug, like where did things go wrong, right? So you can enable this schema mapping inspection report, and what it did here is it figured out that, oh, hey, you have some unmapped fields here. That date created and that price, I'm glad you declared that in your API, but I can't find a data fetcher for that. I don't know what that is kind of resolving to. So again, it kind of gives you some information as to what's going wrong. We talked about arguments earlier. So in your GraphQL side, you have an argument. How do you bind that to an argument over on the Spring side? Well, you use the @argument annotation. You can also use complex arguments. So here I'm saying, hey, I have an order criteria. That order criteria could have a bunch of fields like ordered on and status. Again, we can support not only simple arguments, but also complex arguments. It also supports validation. So same way you would in a REST API. If you need to validate some data that's incoming, in this case, I am looking for some orders. I want to make sure that specific things on the order criteria are validated. I can use the @valid annotation. Something else we looked at before is, in this case, I have this customer, right? This customer has things like ID, first name, last name, email, but it also has orders. So the customer is going to return a collection of orders. By default, in my entity, I have some JPA going on so that when you call orders, it's going to make that association and fetch a list of orders associated with that customer. This is great. This is a great kind of out-of-the-box experience, but what if I want to customize that? What I can do is override that data resolver. So in this case, I have a customer controller, and in that customer controller, I define a schema mapping with the name of orders, because again, that is matching the name of the field in the schema. And I'm saying, don't use JPA to go kind of fetch all those from the database. Maybe I need to call another service. Maybe I have a microservice in our organization that deals with orders. So now I'm kind of overriding that default behavior, and now I can say, hey, this is the data fetcher for that particular field in my schema. So you get complete control over kind of tying those two together. Again, we looked at mutations earlier. We have a mutation mapping here that allows you to insert data or modify it. So we have this create product. How do we kind of tie that together? We have the @mutation mapping similar to the @query mapping. And so this is making sure that that is a mutation type. So in that case, we're taking in a title and a description, and we're able to kind of send that off to the repository and persist it. Cool, so remember input types. We have our mutation mapping. What about those input types? So I have that input, that product input type on the schema side. How can I use that on the Spring side? Well, again, that is any type that we want it to be on the Spring side. So I just created a record type called product input that has those same types of fields. And now I can use that, and we can bind to it using that @argument annotation. What does that look on the client side? Well, hey, I want to create a product. Here's a title and a description, and that will return back the new ID, title, and description. You can also bind to full arguments. So here I'm saying use the @arguments annotation and just define a generic map string of objects. And now anything that comes into there, I can kind of bind to that. So in this case, I'm passing title and description as I did before, but they aren't really defined, right? They're just a generic map of arguments. So how did I know about all of these different annotations that I could use in my controller arguments? Well, the documentation, of course. So if you go into the Spring for GraphQL documentation, there's a schema mapping handler section where you can figure out what are the different arguments that I can use in my handler mappings. And there is a very flexible signature there, so we can use a bunch of different arguments. So check out the documentation. The other thing I want to point out is the graphical UI. So when you build out a GraphQL application, you need to enable the UI by default. By default, it's disabled because we don't want to just kind of open this up for anybody to hit in production, right? So if you enable this, run your application with a schema defined, there's some really nice things going on here. On the left, there is some documentation. Who's written some APIs in REST and had no idea what methods were available, or talked to another team and go, I don't know what API this is or what I can do with it, and you have to hunt down someone to figure out what's going on there. Because there's a static type system here, we have nice documentation right out of the box. So quickly I can see what methods are available. This is all the queries available to me. So I know that all products is going to return a collection of products. If I click on product in there, it'll actually show me all the fields available in product. In the middle is where I can kind of type out my queries. This, again, I don't like using the word test. This isn't a place to test them, but it's a nice place to explore them, especially if you're not used to writing the query language. Again, it's a little different at first. You got to kind of take some time to learn that. This is a great playground to do that in. The nice thing is you get really nice IntelliSense too, so as I start typing out all, it will give me a list of queries available there, as well as the different fields. So then I can execute it, sends it to the Spring side, executes it, and this is what we get back. So the graphical UI that you get right out of the box is really nice. Okay. So I want to just talk a little bit about some of the nice features in Spring for GraphQL, and I'll start with observability, really our insights into how things are working. So we know that in Spring Framework 6 and Spring Boot 3, there was a big theme around improving observability across Spring applications. Spring projects now have their own built-in instrumentation for metrics and traces, and GraphQL is really a good case for this, right? Because GraphQL can fan out data fetching. It may talk to one REST API to get orders. It may talk to a database to get the rest of the customer information. It may grab information from cache. So there are different touch points here, and we need some observability into that to find out what's going on in our application. So I'm creating a new application here. I'm choosing web, Spring for GraphQL. I'm using Spring Boot Actuator to bring in those metrics. In this case, I'm using Docker Compose, and I'm also pulling in Zipkin to enable those trace and span IDs. So once I create this project, I go ahead and create a query. So in this case, I'm saying, hey, I need to get all of the customers, and inside of there, I need to get all the orders for that customer, or for each customer. And inside of orders, I want some information about the product. So we send that off, we get all of our data back. Maybe we start to realize that some things aren't happening the way we expect them to in production. So here, because we're collecting those metrics behind the scenes, I can go into Zipkin, I can go ahead and see my request here, I can drill into that to get a little bit more information about that. So I see at the top level, we make a post to /GraphQL, then we see the GraphQL query, and then for every field in that selection set, we will see a corresponding line. So we know that the call to all customers took 51 milliseconds, the call to all orders for that customer took 21 milliseconds. And what this does is really gives you some insight. So if orders was something maybe we were talking to over the network, maybe we had another microservice that dealt with pulling those orders back, we can start to get some insights as to where things are going wrong in our application. Cool, pagination is something new in GraphQL 1.2 based on the cursor connection specification. And what I like about this is pagination, you could kind of roll your own before this, but the problem with rolling your own means that somebody else can kind of roll their own in their service as well. So now in your organization, you have all these different services kind of rolling their own, and it doesn't really work out, right? You need that kind of unified model across the org. So pagination is based on the cursor connection specification, which allows you to navigate large result sets. The way it does this is by using a pattern called connections. So we talked about those schema types, those object types, the different operation types. There's a new type in the schema called a connection. The nice thing is you don't have to create these types. They're automatically created in Spring for you. So any connection type has something called edges. And inside edges, you'll find things like page info. So hey, how many results came back? What page are we on? And then you'll find a node, and the node is the thing that we care about. such as a product, a customer, an order. So again, these are created for you on startup. So here I define two fields. One, orders, that returns a collection of orders. And by default, that's going to return all of them in the system. And just to show the contrast, I have a paginated orders. You'll see the type on the right, the return type, is an order connection. Again, that is not defined in your schema. Spring is creating that for you. Now we can take in arguments like first, last, before, and after, and this allows us to get just like the first 5 orders in the system. How does that work on the Spring side? We've created this mapping, or we've created this method in our controller here, and because its parent is a customer, that will be an argument that we can get right away. Then there's also this new feature in Spring for GraphQL 1.2, which is that scroll subrange. So now I get access to the offset, limits, sort by, etc. So now I can delegate this to a repository, and thanks to new features in Spring Data, which now support limit arguments, I can now say, hey, find by customer, here's the position, here's the limit, I want only the first 10 records, and here's how I want you to sort them. So that combination of the connection type in Spring, and in this case, using Spring Data's limit support, I can now support pagination out of the box. So again, this looks a little different, right? Because we're not just asking for the orders back. What we're saying is paginated orders is going to return page info and an edges. And inside the edges, that node is going to be the thing that we care about. What happens when we get that back? We just get the 3 that or 2. We're asking for 2 here. So. Also, we have security support built around Spring Security. So it's a little bit different than REST, right? Because in REST, we have all those different resources. We have maybe like a /API/products, /API/orders. And around those resources, we could define some security constraints. In GraphQL, a little bit different. We have one endpoint. We have a post to /GraphQL. So how do we secure different queries or different mutations in our application? So here we can use annotations in our controller methods, like Spring Securities @secured, and we can say, hey, anybody who tries to access the create product method, which is basically the mutation on the GraphQL side, they need to be logged in, and they need to be authenticated, and they need to have a role of role admin. What that looks like, if you try to make a call without it, it would go ahead and return to you 401 forbidden. Cool, but also on the GraphQL UI side, in the schema, or in the graphical user interface, you can also provide this as a header. So in this case, I'm using basic authentication, but I'm gonna send this query, I'm gonna pass that as a header over, and then I can go ahead and validate my queries there. The other thing is you'll have context propagation for different transport layers. So if I didn't want to do this in the controller level and I wanted it more in the service level because I have different controllers calling that service, it will propagate down to there as well. And then also you can have access to the authenticated principal. So if in an all orders situation, I may not want all orders in the system, I want all orders for whoever's logged in, you can get access to the authenticated principal there. All right, and then it supports testing out of the box. I'm gonna fly through this pretty quick, but we have a Spring Boot starter for that. We have slice tests that allow you just to kind of focus in on the GraphQL bits. You can do so without the specific transport layers, so this doesn't involve any HTTP. They're pretty easy to write. We see that we have a query here, we can pass it in. There's a nice Fluent API there to kind of test these out. So I'm gonna kind of fly through this because I'm running out of time, but GraphQL features, so the things that we talked about, there's support for things like batch loading, error handling. There's a GraphQL client if you need to call another GraphQL API. There's GraalVM native image support, a whole bunch of data integration and more. So I think that's it. Let's stay connected. You can follow me at @TheRealDanVega on Twitter. You can email me, learn more about me at danvega.dev. Please take a survey if you liked it. If you didn't like it, I understand. Just take the survey and let us know let us know your feedback. With that, we will try to get to 1 or 2 questions real quick. Thanks. Any questions? Can you use the microphone, please, right here? Oh, yes.
So I noticed that you use Spring used the window abstraction.
Yes.
Why did it not go with page, which is the existing abstraction?
Yeah, so the question was, why use window in the paginated result instead of, there are a bunch of different options in Spring Data for pagination. I would say go through and look through the Spring documentation on when to use what. It's a little confusing because there's so many options, but basically the window allows you to basically, if I'm in a view of these 10 and something gets added to it, then it doesn't need to like reshuffle. So there's a use case for that, and especially in GraphQL. You could have used the other things that are supported in Spring Data, but in this case, it actually works out a little better. I would say check out the documentation because there are a lot of different ways that you can support pagination. Any other questions? Okay, cool. Thank you.